After Einstein's photon hypothesis, de Broglie had a brave idea. Light was traditionally considered to be a wave, but light is also particles, the photons. But how about things traditionally considered to be particles? Are they wave as well? De Broglie said yes. It is the famous particle-wave duality. Particle is wave. Wave is particle. Everything is matter wave. A matter wave has both momentum and wave vector. The magnitude of the wave vector is 2 pi divided by wavelength. The direction of the wave vector is the direction of wave propagation. De Broglie relation says that the momentum of the matter wave is proportional to its wave vector. The proportionality coefficient is h bar. You can pause the video here to check the example by yourself. We can use de Broglie relation to derive the Bose fourth assumption. For circular motion, the angular momentum equals momentum times the radius. The momentum can be expressed in terms of wavelength. On the other hand, the matter wave must repeat itself after one cycle. So, the perimeter of the circle must be an integer multiple of the wavelength. Combining the last two equations, we get the Bose fourth assumption. The particle-wave duality of electrons can be proved by the double-slit experiment. In the double-slit experiment, there is an electron source and a detector. The detector records the intensity distribution of the electron beam. It can be a film, which is exposed by electrons. Between the source and the detector, there is a plate with 2 slits. For simplicity, we call them slit 1 and slit 2. We first do experiment with only slit 1 open. Then we do experiment with only slit 2 open. Finally, we do experiment with both slits open. If the source emits classical particles, the intensity from 2 slits open is the sum of the intensities from the slit 1 open and slit 2 open. For example, the intensity from slit 1 open is marked with white circles. The intensity from slit 2 open is marked with black circles. Then, the intensity from both slits open is the black and white circles combined. If the source emits wave, we will see interference pattern. For example, the intensity from slit 1 open is I1. The intensity from slit 2 open is I2. The intensity from both slits open is not I1 plus I2. When the waves from the slits interfere constructively, the intensity is enhanced. When the waves from the slits interfere destructively, the intensity is weakened. The double-slit experiment of electrons shows clear interference pattern as waves. It proves that electron is wave. But this experiment does not deny that electrons are particles, because electrons can be shot one by one. Even if electrons are shot one by one, the interference behavior can still be observed. That means the interference pattern is not caused by the interaction between the electrons. An electron interferes with itself. In conclusion, an electron is a matter wave. It has particle-wave duality.